Hi guys. Today I would like us to talk about multiplying fractions with reducing. So far we've learned how to multiply fractions, and you've always known how to reduce, well, since last year. But what I want us to talk about is another way to do the reducing to make it a little bit easier for you. So I'm going to do this problem first, just with the way we know how to do multiplying right now and the way we know how to do reducing. And then I want to show you an easier way to do it. All right, so when we multiply fractions, we just do numerator times numerator. That's 20. Denominator times denominator. I'm going to count like I would with 15s. I know that 4 15s make up 60 because of a clock. So I have two sets of 4 and 8. So it's going to be 60, and 60 is 120. And now you might say, well, I don't like your method. I would rather just do 8 times 15. That's fine. Just go ahead and do it off to the side. 8 times 5 is 40. Put down the 0, carry the 4. 8 times 1 is 8 plus 4 is 12. Okay, and then we have to reduce. So these actually aren't too bad. But I might notice that 20 and 120 both have a 10 in it. So I'm going to cancel this out. 20 divided by 10 is 2. 120 divided by 10 is 12. And then I would say, okay, well, 2 and 12 are both even, so they both have a 2 in it. 2 goes into 2 once, 2 goes into 12 6 times. So this would be 1/6, right? Which is totally fine, but sometimes we're going to end up with numbers that are a lot messier, and it's going to be more difficult to reduce. Let's say we had something like 3/4 times 10/21. 3 times 10 is 30. 4 times 21 is 84. And then I look at that and I say, oh gosh, what factors do they have in common? Well, they're both even, so they could do it 2. They're both divisible by 3. 3 plus 0 is 3, and 8 and 4 is 12, so they both have a 3. So then let's do 6. So, all right, 6 goes into 30 5 times. 6 goes into 84. I don't even know how many times. Let's go over here and do 6 into 84. I'm going to use short division. 6 goes into 8 one time. 1 times 6 is 6. 8 minus 6 is 2. So instead of putting the 2 down here and bringing down the 4, I'm going to put the 2 up here. 6 goes into 24 4 times. So this would be 14. And that's 5/14. All right. Again, not horrible, but still we had to do division off on the side here. We had to think for a while about common factors that they share. So let's take these two problems again and look at them in a little bit more detail. So let's say we have 5/8 times 4/15 again. Now, remember, when we get the numerator, this is the same thing as doing 5 times 4. We wrote 20, but I'm just going to write 5 times 4 up in the top, and this is 8 times 15 in the denominator. Now, multiplication is commutative, so suppose I reversed them like that, and I wrote 4 times 5, and I left 8 times 15. And then I unmultiplied them. Right, the answer I get to this problem, 4/8 times 5/15, should be the same as the answer I got to the beginning one, because all along, all I did was multiply them, reverse them, and then unmultiply them. Let's check. If I do 4 times 5, I get 20. If I do 8 times 15, I get 120. On this side, if I do 4 times 5, I get 20. And here I do 8 times 15, and I get 120. All right, so this problem and this problem both have the same answer. Now, why is that a big deal? Well, let's look at these fractions right here. 5/8 doesn't reduce, so I'm stuck with that fraction. 4/15 doesn't reduce, I'm stuck with this fraction. But look at this, 4/8 is the same thing as 1/2. 5/15, 5 goes into each of them. This reduces to 1/3. And then 1/2 times 1/3 is 1/6. That's the same thing that we got up here, but we reduced in this problem when the numbers were small. All right, 4/8, that's very easy to reduce to 1/2. 5/15 is easy to reduce to 1/3. 1/2 times 1/3 is 1/6, is a very easy thing to do. I could reduce in this one. I could not reduce up and down in the original one. So what happened? Well, essentially what I did was I flip-flopped the numerators, all right? I flip-flopped them, and what I ended up with was an equivalent fraction or an equivalent problem, but each of the two fractions reduced, all right? Let's try it again, because I'm sure this is confusing you, but let's try it again. Let's do it with a 3/4 times 10/21. Again, 3/4 does not reduce. 10/21 does not reduce, but our answer did reduce. Let's see why. All right, again, if I multiply, this is the same thing as 3 times 10 over 4 times 21. Because multiplication is commutative, I can reverse these and do 10 times 3. I'm going to leave the bottom the same, because if I switched both of them, I would just end up back with the same thing. Now I'm going to unmultiply. I'm going to separate them again into two fractions. This is 10/4 times 3/21. All right, answer to this is 30/84. Answer to this is still 30/84. But remember, this, neither fraction reduced, but here, this, they both have a 2 in it, so this is 5/2. Just ignore the fact that it's an improper fraction, it's okay. And this, they both share a 3. This becomes 1/7. Then this becomes 5/14. Exactly the same thing that we got when we did it, when we multiplied first and then reduced. But again, look, we're reducing here when the numbers are a lot smaller, which makes it a lot easier to reduce. All right, so what does that mean? Let's take another problem. Let's say we have 21/22 times 2/3. All right, again, we could do this whole switching the numerator thing and rewriting it as, again, I'll skip the steps in here, but what we should get when we switch the numerators is 2/22 times 21/3. All right, again, if we just look at what this is going to be, it's going to be 42 over 66. This will also be 42 over 66, but again, doesn't reduce, doesn't reduce, does reduce, does reduce. This one would become 1/11 times, this would become, 3 goes into both of them, 3 goes into 21 7 times, and 3 goes into 3 once. This would become 7/11, and that would be our final answer. All right, so anytime we have two fractions, we could always say, well, it doesn't reduce, doesn't reduce. Let me try flipping them around. But here's the other way that we're going to do it. And let me do this problem one more time. 21/22 times 2/3. Instead of having to do the flipping around part, let me just say, well, if I did flip them around, this would be one fraction, and this would be the other fraction. And I would say, if I switch them, would this fraction reduce? Yeah, it actually would. 21 and 3 both share a common factor. If I switched and made 2 the numerator of the 22, would these reduce? Yeah, they actually share a common factor of 2. So again, you could say, well, since I see that they will reduce, I would like to rewrite them as 2/22 times 21/3. But again, I want to show you another way. So first we have to acknowledge that yes, if we did switch the numerators, we could cancel or we could reduce. But instead of writing it, because again, we're going to have problems that get much bigger than this. We don't want to have a lot of steps that we have to do. So at this point, when you realize that they could cancel, here's what we do. It's called cross canceling. All right, cross like this, cross canceling. So we're going to cross along the diagonal. We're going to cancel along the diagonal right here, because I could always switch the numerators and make a fraction that did simplify. So what I'm going to do is I'm going to look along the diagonals and I'm going to say, do 3 and 21 share a common factor? Yes, they do. They share a common factor of 3. How many times does 3 go into 3? 1 time. How many times does 3 go into 21? 7. All right, so like this canceling that I did right here, I'm just going to do it while it's still in its initial position right here. And I'm going to cancel along the diagonal like that. Same thing here, along this diagonal. I'm going to say do 2 and 22 share any common factors? Yep, they do. They share a common factor of 2. How many times does 2 go into 2? Once. How many times does 2 go into 22? 11. Now, this is the part that I feel like you're going to make a mistake on because there's a lot going on here now. You've drawn the loops, you've got the canceling out here. It's easy to miss a factor, so just be careful here. So I'm going to say what's left along the numerator here is a 7 and a 1. 7 times 1, 7. What's left along the denominator, an 11 times a 1, that's 11. And I get my final answer. All right, let's do another one. Let's say we have 4/15 times 5/6. Whoops. All right, so again, instead of switching the numerator and seeing, do they have anything in common, I'm going to just kind of draw these light loops right here. Don't go crazy because then it makes it even harder to see, so don't do something like that. All right, just do a nice loop, a nice light one. All right, just barely, just so basically only you can see it. Right, and again, right here. Right, and I'm going to say, do 5 and 15 have any factors that they share? Yes, they both share 5. How many times does 5 go into 5? 1 time. How many times does 5 go into 15? 3. Then let me look at this diagonal right here. Do 4 and 6 share a common factor? Yes, they do. They share a common factor of 2. So 2 goes into 4 twice, 2 goes into 6 3 times. Right, now pay attention to all these guys. It's, again, this is the spot where you make a mistake because you just maybe forget one. So 2 times 1 is 2. 3 times 3 is 9. All right, let's try another one. Let's try 5/18 times 2/5. All right, again, instead of rewriting, I'm just going to look and say, if I did rewrite, these two would be a fraction, numerator and denominator. These two would make a fraction, numerator and denominator. So then I'm going to say, do 2 and 18 share a common factor? Yes. 2 goes into 2 once. 2 goes into 18 9 times. Do 5 and 5 share a common factor? Yes. 5. 5 goes into 5 once. 5 goes into 5 once. I like to draw mine so that they're not in the loop or on the loop because it makes it easier to see. Numerator is 1 times 1 is 1. 9 times 1 is 9. That is our fully reduced fraction. Again, think back. If we didn't do that, we would have 5/18 times 2/5. We would end up getting 10 in the numerator. We would get, gosh, 5 times 18, that's 0. Carry the 4. 5 times 1 is 5 plus 4 is 90. And we would have to cancel at this point. And we would get 1/9. All right. And again, you might think, Mrs. Taylor, that's not all that impressive. That would have been easy to reduce. But in our Professor B workbook pages that I'm going to give you, you'll see that there are ones that are not quite this nice right here that, that reduce but not easily. All right. So this method in the long run is definitely going to be easier. Okay. I'm going to have you come back in just a second and we'll practice with some more problems. So, and you'll need the worksheet that I attached. You'll have to have that printed out. Bye.